Welcome to Meki Study Circle channel. In this video, we shall see how to do the computer drafting of the development of the lateral surfaces of the solids. In this problem, we have a hexagonal pyramid of sides of base 35 mm and 65 mm height, which is resting on HP on one of its base and the sides being perpendicular to VP. Also, the pyramid is cut by a plane which is inclined at 30 degrees to the HP and perpendicular to the VP and is intersecting the axis at a distance of 30 mm above the base. We need to draw the development of the remaining portion of the pyramid. So here we need to understand that the type of the solid given to us is a hexagonal pyramid which is having its sides of 35 mm and the height of the axis being 65 mm, and also it is resting on HP in such a way that one of its base sides is perpendicular to VP. So this condition is nothing but we need to construct a hexagon in such a way that it is resting on one of its edges. Only then the edge will be perpendicular to the VP. Next is it is cut by a plane which is inclined at an angle of 30 degrees to the HP and is perpendicular to VP and is intersecting the axis at a distance of 30 mm from the base. So with this data, let us see how to draft the solution for this problem statement. So we'll begin the construction of the solution by selecting a line of thickness 0.18 mm and draw a line of any arbitrary length. So this is the XY line. So now we'll select a line of thickness 0.13 mm and then construct the hexagon. So the hexagon is having an edge length of 35 mm followed by angle of 0 degrees. The next parameter is 35 and the angle being 60. Next 35 and the angle being 60 into 2. And next is 35 mm length and the angle being 60 into 3. 35 and the angle being 60 into 4. So 35 and the angle is minus 60 degrees. So now we will select this entire hexagon and then rotate this in such a way that one of its edges will be perpendicular to the VP. So for that, select the rotate option, select these two corner points and rotate it in such a way that it becomes perpendicular. Now move this to a convenient position like this. So as you can see that the two edges are perpendicular to the vertical plane, that is VP. So since this is a pyramid, let us draw the triangular faces by joining the corner points of opposite directions, and this completes the 6 triangular faces of the hexagonal pyramid. So go for the smart dimension and just show the dimension of any one edge which is equal to 35 mm. Now we shall complete the front view of this pyramid by drawing the projection lines from each of the corners and intersecting the XY line. So the height of this particular pyramid is 65 mm. So draw a line of length 65 mm. So from the end point of this line, that is the vertex or the apex of the pyramid, join to the endpoints of the projection lines drawn from the corners. And this completes the front view. So now let us annotate this. So first let us begin by annotating the XY line and also the reference planes. So this is X and this is Y, followed by the planes VP and HP. So now we will start from this corner. So this is corner A, this is corner B, corner C, corner D, corner E, and then the corner F. Also, this is the apex of the pyramid, which is O, and O1 is the center of the base of the pyramid. Coming to the front view, O dash is the apex of the pyramid, and here for the observer, C dash is visible and the corner D dash is not visible, so in the bracket. And similarly here, this is B dash and inside the bracket it is E dash. Also here we have got the corner A dash first, followed by the corner F dash. So this is the annotation of the front view of the pyramid. Also here we have got O1 dash, So now this completes the front view of the pyramid. Go for the smart dimension and show the length of the axis. So now let us take a line from the base of the pyramid, and the length of that line will be equal to 30 mm. So from here, let us draw a line which is inclined to the HP at an angle of 30 degrees. And this will be the cutting plane. So select this line and change this line type to the cutting plane. And then let us extend this line by using the extend to next option until it is interacting with all the slant edges. So go for the trim option and trim this. Go for the distance between, select this endpoint and show the length which is equal to 30 mm. And also go for the angle between, select this cutting plane and the base of the pyramid. So this is 30 degrees inclined to the horizontal plane. So this is the cutting plane. So now we shall go for the line option. Select a line of thickness 0.50 mm. So let us highlight all these slant edges, including the base of the pyramid, which is interacted by the cutting plane and is visible to the observer. So this is the remaining portion of the prism, and we need to draw the development of this remaining portion. So we'll assume that the top portion is chopped off. So now let us annotate the points of interaction. So first we'll consider the slant edge OA, and it is interacted by the cutting plane at a point 1 dash in the front view and at the point 1 in the top view. And next edge is OB, and here is OB. So let us annotate this point as 2 dash here, and then in the top view as point 2. And next we have got the next slant edge, that is OC, which is interacted at the point say 3 dash in the front view and point 3 in the top view. So followed by the next slant edge, that is OD, so which is exactly behind this particular triangular face, and that point will be 4 dash. So point 4 here. And next we have got the edge OE, which is exactly behind OB, and that point will be 5 dash. And next the final point is behind OA, which is equal to OF, and that point is say 6 dash. So these are the 6 salient points, that is the points of intersection of the cutting plane with the respective triangular edges of the hexagonal pyramid. So go for the line option now. So select the line of thickness 0.50 and just highlight the top view, which is visible as it is. So now we'll go for constructing the development. So first let us check if any of the slant edges are perpendicular to the, parallel to the VP. So none of the lines are parallel to the reference line. So what we can do is, let us take the line option of thickness 0.13 mm, draw a line from the apex which is parallel to the XY line, go for the arc by center point, measure OC, and then draw an arc of the same dimension intersecting this line parallel to the reference line. From here, let us draw a perpendicular from the end point. Let us join it to the apex of the pyramid. So this is the true slant edge of the hexagonal pyramid, which will be required for constructing the arc. So now the next part of construction is transfer all these points to the true slant edge by drawing a line perpendicular to the XY line, parallel to the XY line. So these are the points 1, 2, 5. Okay, so this is 1, 6, 2, 5, and this point is 3, 4. So these are the reflection of these points on this true slant edge. So now the true slant edge measures 73.82 mm. So now let us annotate this point as C1 for reference. So we'll consider OC1 as the true slant edge in the top view, and here this point will be C1 dash in the front view. So let us annotate this as C1 dash. So O dash C1 dash is the true slant edge. So that radii will be used to construct the arc. So go for arc by center point, select a line of thickness 0.13. So from any arbitrary point, sweep a arc of radii 73.82 mm, 73.82, and then sweep an arc. So now use the line option, connect one end of the arc to the center point, and from this point as the reference, let us divide this arc into 6 equal parts because it is a hexagonal pyramid and there are 6 triangular faces. So go for arc by center point again, and each face shall measure with a base of length 35. So draw an arc of radii 35. So again from the point of intersection, construct an arc of 35 mm. So repeat this step until we get 6 equal parts. So always select the point of intersection as the center point for the arcs that you construct. So now let us select the line option and join the point of intersection of the arcs with the main arc to the center point of the main arc to get the triangular edges. So now we have got 1, 2, 3, 4, 5 and join this. So before you join, let us just cut an arc of length 35. So this is the end point. So sweep an arc of radii 35. So it is going to cut somewhere here. So we can use the extend to next and extend this arc till here. Then select the line option. So from the apex, join this to the end point of this arc. So from here, draw the base of the pyramid by connecting all the endpoints with a straight line. So since it is a pyramid, it will be having triangular faces, and all these straight lines represents the triangular faces. So show the measurement of the radii of the arc and also the measurement of any one side which is equal to 35 mm. So now use the trim option. So to trim this construction arcs, so you can retain the main arc, only the construction arcs could be trimmed. So this represents the initial cut section of the hexagonal pyramid. So there are totally 6 triangular faces. Now let us annotate this. So this is the apex of the pyramid O. Let us use the capital letters because these are all the actual views: A, B, C, D, E, F, and then corner A. So these are the initial triangular faces of the hexagonal pyramid. But we need to show the development of the remaining portion of the pyramid after it has been cut by the cutting plane. So now let us measure the points. So go for the distance between, select the apex, and then 1 dash and 6 dashes at a distance of 54.4 mm. So what we will do is we'll select the line option again. So from the apex, draw a line of length 54.4 mm on these edges, that is OA on both the sides 54.4. Also we have got the point 6 which is along with the point 1, and 6 is on OF. So draw a line of 54.4 mm length on OF also to get the point 0.6. Similarly, go for distance between again from the apex. Measure the distance of 2 and 5, which is equal to 39.75. So go for the line option. So on OB, draw a line of length 39.75. So up to two decimal places is sufficient. And also there is a point 5 on the slant edge OE. So from O, draw a line of length 39.75 mm on OE. And next on OD, we need to have the points 3 and 4. So go for the distance between, and from the apex, select this point 4, so which is equal to 31.32. So now let us draw a line of length 31.32 on OE. So select this line OC and OE 31.32. Also on OE. Okay, that is OC and OD 31.32. So now go for the line option of thickness 0.50 mm line. So just sweep the cursor, you'll get the endpoint of the lines that you have constructed on each of the slant edges, and try joining them, that is to the endpoints, so that you get the developments. And now join it to the respective endpoints, complete the base of the pyramid, then join it back to the points on the slant edges, to the corner points on the base. So this is the development of the hexagonal pyramid when it is intersected by a cutting plane in such a way that it is bisecting. Okay, it is not bisecting, so it is just cutting the axis at a point of 30 mm from the base and is inclined at an angle of 30 degrees to the HP and is perpendicular to the VP. So we can just go for the annotation and label these points as 1, 2, 3, 4, 5, and then 6. So these are the points. So 3 is here, this will be 4, this point is 5, and this point is 6, and this point is 1. So just delete the old annotations. So this point is 4, this point is 5, and this point is 6, and this is 1. So let us write development inside this part, indicating that this is the development of the remaining portion of the pyramid. So this is the development of the hexagonal pyramid. We can also highlight the triangular faces with a line of thickness 0.50 mm. So just join all this and you get the top view of the pyramid. So go for the line option, 0.13. So 1 is here, 6 is here. Then similarly, we have got 3 and 4 here. So you can use the split option here, which is just below the extend to next. So select the entire line and this point of intersection as the next point, so it becomes separate entity. Select the entire line and this endpoint so that there are separate entities that is split, and then just delete this and this. So this is the exact view of the hexagonal pyramid. So with this we complete the development of the hexagonal pyramid as given in the problem statement. Thank you all for watching.